Hi guys, today we're going to go over theoretical probability. These are the notes for today. So we're still going over probability, but this is theoretical. Okay, when I think of theoretical probability, I think of being in a perfect world. Okay, why do I say this? Because think of a coin, okay? Or let's say this counter, this counter. This counter has one side yellow, one side red. So if I ask you, what are the chances that it lands on yellow, you're going to say half. You have half the chance of landing on yellow, half the chance of landing on red. So basically 50%, 50% yellow, 50% red. Okay? And then if I ask you again, if I flip this counter 20 times, how many times is it going to land on red? Well, in the perfect world, because it's half, you would say 10, right? 20, I flip it 20 times, it's going to land 10 on red and 10 on yellow in the perfect world, right? Theoretically speaking, if I say that I'm going to flip this counter 40 times, then how many times would it land on red? Good. It would land 20, right? 20 times on red, 20 times on yellow. In a perfect world, that's what it would happen, theoretically speaking. Okay, so that's what we're learning today. Um, that what happens in a perfect world, okay? Theoretically speaking, you would have half the time landing on yellow, half the time landing on red. Does that really happen in real life? I no, it doesn't. But we're not going to speak of that right now. We're just thinking of theoretical right now in the perfect world. Okay. Now there are some words here that are going to help us to know the how to work out compound theoretical probability. And these words are and then. If we see these keywords, we're going to know that it's going to be a compound probability. Okay? So, knowing that, we're going to go ahead and go into number one. Okay? It says, what is the probability of spinning a blue on the spinner and flipping heads? Okay? So, we want to spin a blue on the spinner and flip heads. The keyword here being and. Okay? And when we see and, we're going to multiply. Now, why is that? So, I want you to think of me saying, okay, I'm going to give you $100, but only, or let me put it this way. If I say, I'm going to give you $100 if the spinner lands on blue or you flip a heads. I'm saying the word or right now. So if you land on blue or on heads, I'm going to give you $100. So you have a lot of chances because I'm saying or. So it's like if I spin the spinner and flip the coin, as long as I get either blue here or heads here, I'm going to get $100. That's a lot of chances. But if I tell you, for you to get $100, I need you to land on blue and heads. So I need both things to happen. That's what and means. And means you need both things to happen. Well, then your chances just went down. Okay. So for or, we were adding chances. We were saying either you get blue or heads. We were adding chances. You were getting more chances of getting those $100 because you're saying or. But when you say and, your chances are cutting down. So we cannot add anymore. So what we do is we multiply. So let's think of this first one. So here's a spinner. You want the spinner to be on blue. The spinner has to be on blue. and you want the coin to land on heads. So you go to the spinner and you count your blue ones. There's 3 blue out of how many? 1, 2, 3, 4, 5, 6, 7, 8 out of 8. And then you look at the coin. How many heads? A coin has heads and tails. It has 1 heads out of 2 sides. And we're going to multiply. Again, why am I multiplying? Because and. So we're going to do 3 times 1, 3. 8 times 2, 16. Can I simplify? No. So because I cannot simplify, this will be my answer. So what is the probability of spinning a blue and flipping heads? 3 out of 16. Okay? So, number 2. Marcus has several marbles in a bag. He will select a marble, put it back, then draw another. And by draw means get another, okay? I want to know what is the probability that he first gets a blue, then a red. Here, it doesn't say and. It doesn't say and because here it was 2 different things. It was a spinner and a coin, so that's why it says and. Here, it is just, it's the same bag. So instead of saying and, it's going to say then, which still means multiplication, because you want to get a marble and then get another marble, okay? But it's saying then because it's the same bag, okay? So first of all, we're going to figure out how many marbles are in a bag. So I'm going to go ahead and count. I'm going to say 4, 5, 6, 7, 8, 9, 10, 11, 12. There is 12 marbles in this bag. And we're going to get a marble, select a marble, and then draw another one. So it's going to be the first and the second. The first time, what is the probability that first he gets a blue, the first time we want a blue marble, and then a red marble, and the second time we want a red marble. How many blue marbles do we have? We have 3 blue. 3 out of how many marbles did we have? 12. Times, how many red marbles do we have? 2 out of 12. How come the amount of marbles never went down? Is because he put it back. Okay, so they want to know what is the probability that he gets a blue and then a red. Okay, in that sequence, in that order. 3 times 2 is 6. 12 times 12, 144. So we end up with 6 over 144. Can I simplify? Yes, so I'm going to divide by 2. 6 divided by 2 is 3. 144 divided by 2 is, we're going to divide. And I get 72. Can I simplify again? Yes, by 3. So I get 1 over 24. Okay. Um, we could initially divide it by 6. if you wanted to, but we divided both times, okay? So, number 3. What is the probability of rolling a die and getting an even number than rolling the die and getting an odd number? Here the keyword is then. Why? Because it's the same die. It's the same die. What is a die? A die is this. Okay? So the first time, the second time. So, and a die has the numbers 1, 2, 3, 4, 5, 6. Those are the numbers that are in a die. So we're going to say, well, what is the probability of rolling a die and getting an even number? So the first time you want an even number. So even, and even. So 3 out of 6. That's the first time. Then rolling the die and getting an odd number. So the odds 1, 2, and 3. So 3 out of 6 again. So this one we want it even, and then this one we want it odd. So we're going to say 3 times 3, 9. 6 times 6, 36. I'm going to divide by 9. 9 divided by 9 is 1. 36 divided by 9 is 4. So it's going to be 1/4. So the probability of rolling an even and then rolling an odd right afterwards is 1/4. Okay? Remember, it means multiply. So the keywords are and then. That's how we know that we're going to be creating two fractions and then we're going to be multiplying them. Number 4. Martha has a number cube and a coin. So here's a number cube, here's a coin. Martha rolls a number cube once and flips the coin once. What is the probability that the number cube lands on a number less than 3 and the coin lands on tails? Again, why are we using and here and not then? Because it's two different things. It's a die and a coin. When it's two different things, when they're separate, then you use the word and. Okay. So we're gonna see a die and a coin. On the die, remember on the die we have the numbers 1, 2, 3, 4, 5, and 6. On the coin we have heads and tails. So on the die, or the number cube, you want a number less than 3. So I'm going to say 1 is less than 3, 2 is less than 3. Is 3 less than 3? No, 3 is equal to 3, not less than. 4? No. 5? No. And 6? No. So the only numbers that are less than 3 on the number cube is the 1 and 2, which is two numbers out of 1, 2, 3, 4, 5, 6, out of 6 numbers. Now, and there was a number less than 3. Number less than 3. That's what I wanted. Now on the coin, you want it to land on tails. How many tails does a coin have? 1. Out of how many sides? 2. So you do 2 times 1, 2. 6 times 2, 12. So you end up with 2 over 12. Can I simplify 2 over 12? Yes. By what? By 2. So 2 divided by 2, 1. 12 divided by 2, 6. So 1, 6. So the probability that you're going to land on a number less than 3 and at the same time on tails is going to be 1, 6. Okay? Number 5. Number 5. If you have 10 cards numbered 0 through 9, what is the probability of drawing a 1, replacing the card, then drawing an odd number? So it says here, if you have 10 cards number 0 through 9. So what I'm going to do is I'm going to go ahead and draw those cards. I'm going to draw the cards and I'm going to number them 0 through 9. So there's 10 cards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1. There's 0 through 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are 10 cards that are numbered 0 through 9. And what I want to know is the probability of drawing a 1, we replace the card, then and then drawing an odd number. So we're going to say the first time and the second time. Again, it's then. Why is it then? Because we're using the cards for both the first time and the second time. Okay? Over here, it was and, because it was a die and a coin, two different items. Here, it's then, because I'm drawing two cards, but it's going to be the first time and the second time, and it's from the cards, the same items. Okay? So the first time, it tells you drawing a 1. What is the probability of drawing a 1? So the first time we want the number 1. And then the second time it says then drawing an odd number. So the second time we want an odd number. So here, how many ones do we have? We have 1. We have one number 1 out of how many cards? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 10 cards. Okay? Now, second time you wanted an odd number. Odd, even, odd, even, odd, even, odd, even, odd. So how many did I highlight? How many odd numbers do I have? 1, 2, 3, 4, 5. I have 5 out of how many cards? 10. Okay? So then we're going to multiply. 1 times 5, 5. 10 times 10, 100. Now, so 5 over 100. Can I simplify these two numbers? Can I make those two numbers smaller at the same time by dividing by a specific number? Yes, I can. I'm going to divide both top and bottom by 1. If I do 5 divided by 5, I get 1. If I do 100 divided by 5, I get 20. So 1 out of 20. So the probability that you're going to get a number 1, and then right afterwards you're going to get an odd number in that specific order, is 1 out of 20 chances. Okay? And again, remember that this is compound probability theoretical. Okay? Meaning when you want two things to happen one after another or at the same time. Okay? That's why we're multiplying, because we want two things to happen at the same time. And last but not least, we're going to be looking at number 6. But before I do number 6, I want to explain something a little bit. And I want you to think of, or let me read number 6 and then let me go over it, okay? So a deli prepares sandwiches with one type of bread, whether it's white or wheat bread. One type of meat, whether it's ham, turkey, or chicken. And one type of cheese, whether it's cheddar or Swiss. Find the probability of choosing a sandwich and getting turkey meat and Swiss cheese. So I want you to think when you go to Subway, or if your mom tells you, I'm gonna go to Subway and I'm gonna buy you a sandwich. What do you want in it? So I want you to think of that, and let's say that let's say that you go to Subway and they already have the sandwiches made, okay, and the sandwiches say what they have in it, okay, and you tell your mom, oh, just bring me a sandwich. It doesn't matter what it has in it, just bring me a sandwich. Well, if you just say just bring me a sandwich, it doesn't matter what it has in it, then your mom has a lot of options, right? She has a lot of options to bring you home because you didn't ask for a specific sandwich. So I'm going to go ahead and just get this a little bit out of the way. And I'm just going to say, so we can think of this. I'm just going to say, well, let's say that there were 20 sandwiches. And then you say, well, I don't care what sandwich you bring me, just bring me a sandwich. Then you have 20 options out of the 20 options, right? But if you still have 20 sandwiches and you tell your mom, Mom, can you bring me a sandwich? Just make sure it has that it's wheat bread. And then there's only like 15 sandwiches that are wheat. Then you only have 15 chances. So because you asked for a more specific sandwich, because now you said I want it to be wheat, then your chances, your probability went down. Now you only have 15 chances out of 20 of getting a sandwich. Now, let's say that there's still 20 sandwiches, right? 15 have wheat. But then you say, Mom, you know what? I want it to be wheat bread, but make sure it has ham. Well, you had 15 that had wheat, but out of those 15, only 10 have ham. So your chances just went down. Here you wanted any kind. Here you wanted it to have wheat. Here you wanted it to have wheat and ham. Okay? But then you say, you know what, Mom, you know what? I want it to be wheat bread. I want it to have ham. But can you please make sure that it has, I don't know, that it has mayo? Okay, so what do we understand by this? What I think I think that is the more specific you get on what you want on your sandwich, the less chances you have of getting that. The probability goes down. You used to have 20 options, but because you said wheat, you had 15. And then you said ham, now you have 10. Now you said mayo, now you have 5. So it used to be that when you wanted any kind of sandwich, you had 20 options. But when you got more specific on what you wanted on that sandwich, then you ended up with only 5 options. Okay, so that basically is what probability is. Okay, it's the more specific you want something, or the more and, the less chances you have. Here it was anything, here it was wheat, here it was wheat and, which made it less. Here it was wheat and ham and mayo, so it made it less. So the more ands you put to it, the more things you want at the same time, the less the probability will be. Okay, so that's basically what happened in all of these questions that we were doing right now. And I'm going to go back to them, and I just want you to understand that. So here I said I wanted a blue and heads. So I wanted two things to happen at the same time. I not only wanted the blue on the spinner, I also wanted heads on the coin at the same time. So that's why we end up multiplying, because we had this chance, and then we also had this chance of getting heads. But when we multiply, the chances get smaller. Okay, when you multiply fractions, you get a smaller fraction. Um, I know you can't really tell because of the different numbers it has, but it's actually a smaller fraction. Okay, and that is just because you want more things at the same time. Um, so for instance, here, and let's do number 6, and then we'll keep talking a little bit about this. It is We already said that the deli prepares sandwiches, right? And there is a type of bread. So we have bread. There's two types of bread. It's either white or wheat. There is one type of meat. You can get one type of meat, and it's either ham, turkey, or chicken, and one type of cheese. And you have cheddar and Swiss. They want you to find the probability. They want the probability of choosing a sandwich and getting turkey meat and Swiss cheese. So, and this is very important, okay? We gotta think of bread. You wanted the probability of choosing a sandwich and getting turkey meat and Swiss cheese. Did it tell us what kind of bread we wanted on the sandwich? No. When it doesn't tell you what kind of bread, it means it doesn't care for what kind of bread you give them. So you can either get white or wheat. So you have the two options out of the two. That means whether you give that person white bread or wheat bread, they're going to be happy because they didn't ask for a specific bread. So you have the two options available out of the two options that you had. Now, meat. They want turkey meat. How many turkey meats do you have? One. One out of how many types of meat? One, two, three. So, meat, you want a specific meat. You want turkey meat, and that's only one option out of the three meats. Now, we have also cheese. Okay? We have two types of cheese, and it tells us here that we want Swiss. Do you want any kind of cheese? No, we want Swiss cheese. So that's one option out of the two. And then we're going to multiply. So it's me. 2 times 3 is 6. 6 times 2 is 12. So out of the 12 options that you had, because you were being picky and you were saying, I want turkey meat and Swiss cheese, you have only 2 times 1 is 2, and 2 times 1 is 2. You only have two options out of 12. Okay? Does that make sense? Okay? We are multiplying because if we don't multiply, it's going to look like we have more options. When you multiply, it gives us less options. Why? Because you're being picky. You want turkey meat and you want Swiss cheese. So instead of having those 12 options that you had at the beginning, you don't anymore because you were being picky. Now you only have two options out of 12. So the probability that you're going to get a sandwich that has those two things is 2 out of 12 sandwiches. Only 2 out of 12 sandwiches will have turkey meat and Swiss cheese. The rest of them will not have those two things at the same time. They might have the turkey meat, but not the Swiss, or have the Swiss, but not the turkey. Okay? Only two of them, only two of the sandwiches will have those two things at the same time. That's what and means, at the same time. Okay? So that's basically it, guys. That is what this means. And again, the keywords are and then. And what do? We go ahead and multiply the fractions. And why do we multiply? We multiply so that we can get a smaller fraction because remember, we're asking for more things at the same time. Okay, the more things that you ask at the same time, the less chances you're gonna get it. Okay, I always think of that. I always think of if I want more things, the less chances I get to get it. Okay, in probability. Okay, um, it's really simple to kind of grasp that concept because just think of I don't know of you asking your parents, Mom, can I go to the movies? She might say yes to that, but if you say, Mom, can I go to the movies and buy and I don't know, and then can you take me to Peter Piper? And you said the word and, which means or then, and which means you want more things to happen at the same time. You not only want to go to the movies, but then you want to go also to Peter Piper. So your chances just went down. And if you say, Mom, can you take me to the movies and then to Peter Piper's and buy me, I don't know, some jeans, your chances just got smaller. Okay, the more ends, the less probability you'll have. And end means to multiply and then also. So make sure that you remember that the keywords are then and end. Okay. So if you have problems or if you still are a little bit confused on how to do these questions, please make sure to log in into our Google Meet at your predetermined time so that we can go over any questions you might have on your assignment or on this notes. And that's it for today, guys. I will see you later on if you do log in into our Google Meets. Have a nice day.